Frank.
Great, thanks very much. Afternoon, everyone. I am be walking you through the process that we followed to develop a nutrient profiling model to underpin front of pack labels in South Africa. And then Makoma and Rena will be sharing more about the process a bit later on in the presentations. Just to note that this is not yet a regulation that has been passed, but the South African Department of Health is currently considering it for draft regulations. So in order to develop a nutrient profiling model, it was important that we followed a scientific and stepwise process. And although these are presented as steps, in reality, the steps are very interrelated and interdependent, and decisions made in one step influence decisions in other steps. So the steps we followed were: 1, to determine the target and purpose population for the nutrient profiling model; 2, to select nutrients and food components to include; 3, to select the base, type, and criteria; 4, to select numbers and thresholds; and 5, to evaluate the performance of the proposed model. In order to do this, it was necessary to collect data on the packaged food supply in South Africa, and we collected this at supermarkets in both low and middle income suburbs in Cape Town. We photographed over 18,000 products. However, as it's not required by law for products to have nutritional information in South Africa, we had to exclude a large number, and our final data set was 6,747 products. From these photographs, we were able to extract nutritional information, ingredients lists, and other general information, which we could then use to analyze data based on various nutrient profiling models. During our analysis, we found that of our sample, 76% of the packaged foods were ultra processed, which is quite a large percentage. Once we reviewed literature, we found that the obesity pandemic in our country is advanced amongst both children and adults, and there are high levels of non-communicable disease morbidity and mortality, as well as an increasing consumption of ultra-processed foods. In South Africa, the food environment is skewed towards making unhealthy foods the easy food to choose, and it makes it quite difficult to choose healthier food options. The Department of Health has identified a front of pack labeling, restriction of marketing to children, and restriction of ultra-processed foods as policy priorities in the country. And based on this, our recommendation for step 1 is that the nutrient profiling model should identify unhealthy packaged foods that should be restricted for all South Africans. We compared nutrient profiling models that included both nutrients to limit, unhealthy nutrients like sodium and fat, to those that included both nutrients to limit and encourage. Ones to encourage would be things like fruits and vegetables, fiber, or nuts and legumes. We found that those that included nutrients to encourage were much more lenient than the nutrient profiling models that only included nutrients to limit. And because our purpose was to identify unhealthy foods, it was appropriate for our nutrient profiling model to only include nutrients to limit. Those we identified as suitable were sodium, saturated fat, total sugar with a free sugar qualifier for inclusion, and non-sugar sweetener. Given the resource limitations in South Africa, it was important that the approach was easy to implement and not very labor intensive in terms of having a high administrative burden. And because of this, we identified using an across-the-board approach rather than a category-specific approach, which requires more calculations and administration, as well as using cut points rather than scores, which can sometimes be complex to calculate. And currently, South Africa uses a per 100 gram and 100 ml approach as recommended by Codex, and this makes sense to continue using. Once these 3 steps had been finalized, it was important that we selected which cut points we were going to use and exactly what numbers to include. It's generally an accepted approach to adapt an existing nutrient profiling model rather than developing one from scratch, as there are so many existing nutrient profiling models that are successful, and also because of the cost of developing one from scratch. The most appropriate model to adapt is guided by the decisions that are made in steps 1 through 3. And so based on our decisions, we looked at models that were developed for similar purposes and considered them. We considered the Chilean Warning Octagon 2019 or CWO model, which was developed in Chile for their regulations and has also been adapted by Peru and Israel in mandatory regulations on front of pack labeling. We also looked at the PAHO model, which is used in Mexico for their front of pack labeling and marketing restriction regulations. And we considered the South Africa Health and Nutrition Claims, or HNC model, which was developed for a different purpose, for the purpose of monitoring nutrition and health claims made on foods. But because it was developed in South Africa, for South Africa, we felt it was important to consider. It is based on the FERN2021 model from Australia and New Zealand, and uses both nutrients to encourage and nutrients to limit, and also makes use of a scoring system. And because this was not deemed appropriate for our model, we did not make use of this model to adapt. Similarly, the PAHO model makes use of percentage energy rather than a per 100 gram approach, and thus was not appropriate. We also considered the WHO Africa region model, but because it makes use of categories rather than across the board, we excluded it, and we identified the Chilean Warning Octagon as the most appropriate model to adapt for our purposes. The cut points for our proposed model are similar based on the Chilean models with a few adaptations. So what we propose is that the cut points, as they are displayed on this slide, are for all packaged foods and beverage that contain any added sodium, free sugar, added saturated fat, or non-sugar sweetener, and that the cut points apply per 100 grams for solids and per 100 mils for liquids in the as consumed format. Once we had decided on the nutrient profiling model, it is necessary to evaluate its performance against other existing nutrient profiling models. And in order to do this, we evaluated its performance against the Chilean model, the PAHO model, as well as the South African Health and Nutrition Claims model. Our model is referred to here as the South African Front of Pack Labeling, or FOPL model. For all of these, the first or darkest bar represents total, the second foods, and the third lightest bar is beverages. And based on each nutrient profiling model, the level of non-compliance, or more practically, the likelihood that a product would carry a front of pack warning label if it was used for that purpose, was examined. We found that the health and nutrition claims model was most lenient and least likely to carry a warning label, with 47% of products not carrying a warning label, and the PAHO model was strictest, where less than 20% would not have a warning label. The Chilean model and the front of pack labeling model performed similarly, except for beverages, where our proposed front of pack labeling model was strictest, given the criteria for non-sugar sweetener, as well as the criteria for free sugars rather than added sugars that we made use of. If the proposed model is used, 71% of foods would carry a warning label. Categories where more than 70% would carry a warning label are confectionery, breakfast cereals, soups and sauces, snack foods and dairies, and those where less than 50% would carry one or legumes, vegetables, fruits, and cereals. For beverages, 80% of products would carry a warning label. And unlike other nutrient profiling models, fruit juice would also carry a warning label because of the free sugar qualifying criteria.
2 minutes remaining, Tamryn.
Thanks. Our research results confirm that the proposed nutrient profiling model is fit for purpose and appropriate for use in restrictive food policy in South Africa. If you would like to read more about it, we have published one paper and we do have another one that is under review at the moment. Thank you very much